Hello everyone, welcome to this video. In this video, I want to talk about rational inequalities which involve factors in the numerator as well as the denominator. So this is what we want to solve at the end of this video, but I want to assume that you already have a fair bit of knowledge on how to solve the basic trivial examples. For example, this one on the left hand side. So essentially in this video, I want to take you from this point to this point. And in this transformation, there are going to be some concepts or tools that you are going to be learning, and hopefully you are going to store these tools in your toolkit, and whenever you find a relevant example, you can make use of these tools or concepts. So let's start by the first trivial case, and I've drawn already some stuff just to save some time here. But in order to solve this, we can just add 3 to both sides, and what we are going to get is x is greater than 3. This is something that you already know, but I want to show this information on this number line, and you will see why just in a moment. So let me first give this a name. This is f of x, this function f. I want to be very clear, f of x is just this portion and doesn't involve this operator. So if you consider any point which exceeds 3, for example 4, it's going to make f of x positive, right? So we can basically label or assign a positive sign to this portion of the number line from 3 to infinity. Similarly, we can assign a negative sign to this portion of the number line from minus infinity to 3. So what we have really done is classified the number line, the complete number line, from minus infinity to infinity, indicating which portion is positive or negative. And we have done this for the complete number line. There is no such interval or set of numbers for which we haven't said or argued that that interval is either positive or negative. So if you think about any inequality problem, basically we can view that inequality problem as a number line classification problem, in which we just have to classify the complete number line, indicating which portion is positive or negative. And this seems pretty stupid for this simple example, but you will appreciate its beauty in a more complicated example that we are going to be solving at the end of this video. So let's move on. And I just want to be very clear that this number line classification is just another way of viewing an inequality problem. There's obviously other methods, but this sometimes is very handy, as we will see. But anyway, here's another concept which is quite important. Let's say that you have a real valued function f of x, which involves certain factors, for example x minus alpha, x minus beta, x minus gamma, and there can be many other, but just for the sake of simplicity we have considered 3 here, and I have drawn this graph of this function. Now the point that I want to make is that even though, in order to, let's say that you have some inequality like this, f of x is less than equal to 0 or greater than equal to 0, any combination of these 3 operators. So in order to solve this inequality, one way is just to classify the complete number line, right, like we just discussed. But in order to classify the number line, we have to consider intervals. So which intervals should we consider? Now one natural choice is to consider all those intervals which involve the roots as the endpoints. For example, alpha to beta. In this complete interval, the sign of the function remains constant. In this case, it's negative. And similarly, in this interval from beta to gamma, it's positive. And you are always going to be having 2 extreme intervals, one on the right hand side which involve infinity, for example gamma to infinity, and one on the left hand side from minus infinity to alpha. So in this case the sign is positive, in this case the sign is negative. Now the actual sign is not that important. What I am really arguing is that the sign of the function remains constant within this interval which involve the roots as the endpoint. So the sign is negative in this complete interval, the sign is positive in this complete interval from beta to gamma. Similarly, the sign is negative in this complete interval. And as far as the number line classification is considered, we only have to answer the question whether the sign is positive or negative. It's a binary binary question, and we are not concerned about the actual magnitude of the function. So hopefully this point is clear, and this is just a way of telling you that which intervals you should consider when you get a factorized function of this form. Anyway, let's move on. Now let's solve the actual problem that we discussed previously. So this is the actual problem, and obviously one way is to just to classify this complete number line with respect to this overall function, but this looks very complicated, and there is no direct way or obvious way to classify this function, at least trivially. So let's first classify each of the numerator and denominator and see if we can come up with a more general solution. So for the sake of simplicity, I want to assign a red sign to the numerator function, and I want to assign a blue sign to the denominator function. Now let's start by classifying the denominator function. First, I'm going to plot its roots 1 and 4. And now we just have to consider three intervals, right? Like we just discussed, from -infinity to 1, from 1 to 4, and from 4 to infinity. So starting from the right, from 4 to infinity, in this complete interval, you can take any number and it's going to make this function positive, right? You can just verify by taking any number like 5, and you are going to find that it's positive. Similarly, in this next interval from 1 to 4, one of the factors, which is x minus 1, is positive because that number is going to be on right hand side of 1. But this factor, which is x minus 4, is going to be negative because the number that you consider in this interval is going to be on left hand side of 4. So that means that in this interval, the sign of the function is negative. Now to classify the last interval, which is from -infinity to 1, by the same argument, each of these factors are going to be negative. Two negatives in multiplication are going to result in a positive number. So we have classified the denominator function. Let's do the same thing for the numerator function. First, let me plot its root 2 and 3. Now again, starting from the right hand side, from 3 to infinity, each of these factors are positive, so we can just label a red sign. And I want to be very clear, I'm making this a red positive sign or red plus sign, indicating it's positive only for this numerator function, and similarly for the blue positive sign. So in the next interval from 2 to 3, one of the factors, which is x minus 3, is going to be negative. And finally, in the last interval from -infinity to 2, each of these factors are negative, so it's going to result in a positive interval. So if we look at this picture right here, we have the complete information in order to tell or classify this function f of x, or in order to tell where f of x is greater than or equal to 0. So let's again start from the right hand side and consider those intervals which are of prime importance to us. So 4 to infinity, in this interval, each of the numerator function and denominator function are positive. Therefore, the complete function is positive. So this interval is definitely a part of our solution set. So we can say 4 to infinity is in our solution set. And notice that I'm not including 4 because f of 4 is going to make this function undefined. So let's move on. So the next interval, which is going to be in our solution set, is from 2 to 3. In this, each of these numerator and denominator both are negative, making f of x positive. So 2 and 3, and we can safely assign square brackets to this interval because 2 and 3 are roots of the numerator function and not the denominator. And finally, we will have this interval from -infinity to 1. In this interval, the sign of f of x is positive, and we are not going to include 1. We are not going to include the square bracket with 1 because f of 1 is undefined. So these three intervals are part of solution set. You can just take the union and you're going to get the final solution. So hopefully this video made sense to you.